All right, so the first thing we're going to talk about is connectors. Why is that the first thing? Well, because that's the thing that, interestingly enough, is one of the more complicated things. It has the most variables, and it's the thing that will cause you the most headaches. Okay, if stuff's not working, it's usually because of a cable or a connector. So we're going to learn about all of them and what they do, and some of their eccentricities. So this first series, I've got several examples up here. These are XL connectors. You may know them as XLR connectors. And that's accurate. The R actually stands for this little rubber ring that goes around the edge of it. So they are technically XL connectors, and then later the little rubber ring was added, and so that's what the R stands for. So technically speaking, they're XL connectors, but we just call them XLRs. There are a few things you should know about these. First of all, they can be used for lots of different things. But one of the things that makes them kind of unique, I don't know if, let's see if I can get one you can see, is they actually have 3 pins in them. Okay, so they have pin 1, pin 2, pin 3. And it really only takes 2 wires to carry an audio signal. So why do we have 3 in an XLR? Because there's a way that you can transmit an audio signal down a cable that is a little bit better if you can do it, and that's called a balanced signal. And the idea behind a balanced signal is you actually send the audio down the cable twice. The copy of it is sent out of polarity from the original. So pin 1 on an XLR is the ground. Okay, pin 2 is what's called your hot or your positive polarity, and pin 3 is your cold or your negative polarity. The idea there is that the 2 signals are going down the cable out of polarity, which means they're opposing each other, right? As one's going up in voltage, the other's going down, up and down. That's how the audio signal goes back and forth on the voltage rail. So what then happens is one of the problems we have with cables and connectors is they can pick up a lot of interference through their trip around. Okay, and if all you have is just the 2 wires, the ground and the hot, all kinds of things can interfere with that. Radio signals, just electromagnetic radiation off of lighting cables and things like that. Whereas if you're running a balanced signal, then that interference gets introduced into the cable onto both of those lines. But what's important about it is it gets introduced to both of those wires in the same polarity. Okay, so whereas the signals that we care about that are transmitting these things are doing this across each other, the noise is doing this. Okay, because it gets introduced equally into the cable. And then what happens is, this is called, a balanced signal that's running on an XLR is called a differential system, because it prefers difference, right? It favors difference between the 2 wires. And that the key difference is the polarity. So the idea there is anything that is the same on the 2 wires is going to be canceled out, because on the other end, the negative gets sort of inverted and summed together with the positive, and you get this big boost of signal as a result of that, and it has the effect of canceling out anything that was the same. Okay, because the things that were the same on both wires, one wire gets inverted and then summed together, and then all the stuff that's the same gets canceled out. The stuff that's different, which is the signal you sent, because you sent it down there with a fundamental difference in polarity, it's the thing that survives. And so all of that crud that you pick up along the way gets lost at the other end, which is good. You can avoid that stuff. And the shield, we'll talk more about the shield later when we get to cables, but this is usually a shielded cable that also has some ability to collect interference and dump it into ground as well, but then anything that gets through is usually taken care of by the balanced differential signal. Okay, so what's interesting about XLR connectors is they let you do that, right? There's three pins on the ones we use. You can get them with multiple pin configurations, but the one that we can use most commonly is the 3-pin XLR. And what's cool about them is that even once it bridges out to the connector, all of the wires still stay parallel to one another. Okay, they're never staggered. Okay, those pins hit at the same point, which means there's never a point where interference could come into this line, even when it's connected into it through like this. A lot of connectors, this is a potential for interference that can come into the connector, but the XLR doesn't really do that because any interference that even comes here at the connector is going to be introduced to all three wires equally, right? Because none of them are exposed in a way that the other is not. Okay, so they're kept parallel to one another, and that's a pretty nice feature of this particular connector. That isn't true of others. Okay. Another advantage to these is what I've just done, which is that they nest together. Okay, so usually you have the male end and the female end, and that means when you get to a certain length, you can just tack another one on there and keep going. So generally speaking, the sound comes out of the male end and goes in to the female end. Okay, that's the direction that the sound usually travels on these. There are exceptions to that, but in most cases that's what's going on. There are a few different versions of this connector. This one that I've got in my hand is one from Neutrik called the NC series, NC-MX and NC-FX. So this is from a company called Neutrik. So the F is for female, the M is for male. So NC, Neutrik connector, female, and then X, which stands for the XL type connector. Okay, so this would be an NC3FX. NC3 being 3-pin, F for female, X for XLR. NC3FX, NC3MX. Okay. The advantage to the Neutrik connectors is they don't require any tools to assemble or disassemble them. I can take this one apart without any tools. Okay. Obviously, you'll need a soldering iron to solder it, but aside from that, you don't need any screwdriver to take this thing apart, which is nice. If I can get the strain relief off here. There we go. All right. I can take the whole thing apart. No tools required. Pretty good soldering job. All right. Good job, whoever soldered that. So that's the Neutrik version. There are some other ones. The other more popular one is from Switchcraft, which is this one. Switchcraft is a US company. Neutrik is Swiss, I believe. Anyway, so the Switchcrafts are a little less expensive, and they're more common in the US, but they're not really as useful because they require tools. So you have to have screwdrivers to get this thing apart. And this little screw, which you have to turn in order to get the barrel off to be able to solder, it's a very bizarre screw because it's threaded backwards. So it's still righty-tighty, lefty-loosey, but when you actually turn it to the right, what's happening is it's coming out. In other words, the screw is underneath this barrel, and it comes out to get stuck in there so it won't come off. So as you turn it right, it's actually coming out. And then as you turn it left, it's going in. So to take it off, to loosen it, you do still turn it left, but it's going to travel a different direction from what you think it will, because the screw wants to drop down under there, so then you can take the barrel off. Okay, so what holds this thing together is that screw that pops out through that hole. That's what keeps the barrel in place. So that's a little slight gotcha. And then the strain relief is screwed in as well, which is another kind of weird thing. So I don't really like these because of that, because they have sort of bizarre screws that don't make sense, and they require tools to take them apart and put them back together again, which is really annoying when you have to solder up 100 of them. And that time it takes to deal with a screwdriver is it adds up really quickly. And if it's broken and you're up on a catwalk trying to fix it, the last thing you want to be trying to do is keep track of a little teeny tiny screw. Okay? You just want to be able to like open it up real quick, take it apart, and look and see what's going on, and put it back together again without having to get out the tool bench. Okay? So I don't ever buy these, but you'll see them a lot. We have some in our shop that have been bought along the way. But you know, that's the main difference. Switchcraft and Neutrik, the two most common ones. There's a few others, but you don't need to worry too much about those. You can get them in multiple pin configurations. This is a 6-pin. This would be used for 2-channel Clearcom belt packs. We'll use this. And slight gotcha here, on the Clearcom 2-channel belt packs, the connectors that are on there are Switchcraft connectors. Okay? And theoretically, XLR connectors are standardized. But there's one slight little problem with the 6-pin, which is that the pin configuration is the same between a 6-pin Switchcraft XLR and a 6-pin Neutrik XLR. But what's different is that little key, that little groove that lines it up. It's in a different place on the Neutrik and the Switchcraft, which means technically the pins will line up, but you won't be able to put it in because that little key is not in the right spot, and therefore it won't go in. I learned that the hard way one time, and had to then grind off a bunch of these keys so I could stick them in, but then they wouldn't lock in place because they weren't lined up right. But the pins at least went in and lined up. So that's just a little thing, is that generally speaking, I mean, so like a 3-pin Switchcraft XLR ought to connect to a Neutrik no problem. Okay, and that's how it's supposed to be, but that is how it is for the 3 pins. But you get into some of the multi-pin configurations, and that may not be the case because for some reason they key them slightly differently, and I don't know why. So anyway, you guys can look at these and just pass these around. You can get them in 4-pin XLRs, which you've probably seen on like Clearcom headsets. 5-pin XLRs can be used or are used pretty often for DMX, although only 3 of those pins are actually used in DMX. So it's a 5-pin connector with only 3 pins connected. So I don't know, I guess because they wanted to differentiate it from the audio cable, but there really is no difference. And so actually you can, I've done this before lots of times when I've worked in theaters and the lighting people have run out of DMX cable. I've handed them our mic cable, and it's a little 5-pin to 3-pin adapter. They can be back in business because really the 2 other pins are not used. I have these other ones here, which is just kind of an example of a really bad idea. Generally, I like Neutrik stuff, but this was an idea they had several years ago, which was a solderless XLR cable connector. It has little punch-down slots, so you don't even have to strip the wire. You just sort of punch it down in there, and then this kind of snaps in somehow. Let's see if I can get it. Yeah, something like this. There we go. And that clamps down on the cable, and then it slides into barrel like this, something like that. And there's a little screw you have to put in to get it to stay, but it's very bizarre. And the whole idea, I guess, was people who don't know how to solder, or maybe like install, because a lot of times permanent install stuff, they don't solder, they can actually punch them all down. But really bad idea for a portable cable that you're going to carry around because they just get ripped out all the time. And Stevens Center actually, several years back, bought a couple of snakes from somebody that had these kind of connectors on them, and they didn't last a week. So this is just an example of a really bad idea. Don't do that. All right. So what sort of signal do we run on these? I told you that you can do balance, but this can be in a couple different formats. So you can do microphone level signal, which is almost always a balanced signal, very, very low voltage, low impedance microphone signals. You can also do higher voltage of what we would call line level signals. So professional line level, this is like the thing that would come out of CD players and processing units and stuff like this. This would be professional line level. It runs at a much higher voltage than a microphone does, which so it requires less preamplification at the mixing console. And both of those signals will run just fine on the same sort of cable. You don't need a different kind of cable for microphone level versus line level, unless it's consumer line level, which we'll talk about in a minute. You can also use this for SMPTE timecode can use this, which is called linear time. SMPTE, the Society of Motion Picture Television Production Entertainment, or something like that. SMPTE. The movie people, okay? So this is SMPTE timecode is a time base. It's a way of encoding a clock signal into an audio signal. Okay, so it's actually an audio signal. I mean, you can listen to it. It's like a bunch of pulses, okay? But it's just a regular audio signal. But you might see timecode or SMPTE connections on some mixing consoles and stuff like that, and that's to synchronize with video or something else. And it's usually a balanced signal. It'll run on an XLR cable as well. In fact, QLab will generate a SMPTE signal on an audio output. Okay, and you can use that. There's a digital format that uses the 3-pin XLR called AES EBU digital. That is also it's a 2-channel, so you get 2 channels of audio on one cable. It requires a different sort of cable, a different impedance of cable. It needs a 110 ohm cable to go on it. You can't get a whole lot of distance out of just what we would normally use for microphones. But aside from that, the connector's the same. I don't have one in here anymore. Someone must have stolen it. But there's also another version of the Neutrik XLR called the HD series, and they're waterproof. So whereas the flange on this thing is like open, this one, the other one is sealed, and the barrels are all metal and there's rubber to seal them all. So they're basically waterproof. A little more expensive though. Let's see. Anything else about XLRs I should tell you? I think that's it. All right. So the next sort, I've got a few here. Let's see if I can find some others. Questions while I'm searching? Okay, I think that's all. All right, so I've got various examples here of what you would call phone plugs. Okay, why are they called phone plugs? Well, because the technology was invented for the telephone. It used to be the way telephones worked is everything was a direct point-to-point connection. So you would, before there was things like phone numbers and everything, you would actually pick up your phone, and you would get an operator at the other end. You would tell them who you wanted to talk to, and they would physically patch your phone signal to a person's phone signal you wanted. And if you had to talk to somebody else in the country, it was like, well, they would take you and relay you into some cable that went to the next city over, and then that person would patch you in, and it was like this whole patch that would go all the way over. So there are all these patch bays that were made to do this, and they used this sort of connector called the phone plug. Okay. Well, of course, that technology isn't really used for telephones anymore, but we were able to piggyback off of that in the sound world and use them. So there are various shapes and sizes of these. I've got several of them here. This one I have in my hand is called the 1/4-inch phone plug. 1/4-inch because that's the diameter of the plug itself. And you can get them in 2 different configurations. You can get them in a TS configuration and a TRS configuration. So the T is for tip, R is for ring, S is for sleeve. So TS would be tip sleeve. This would be useful for unbalanced signals. So signals that don't require that, the signal to be sent down twice. So things like, electric guitars, with pickups, they're not, it's not a balanced signal. A lot of consumer-grade equipment is not balanced, and so you certainly wouldn't need the ring for that. The thing is, though, that the two are compatible with each other to some extent. So even if you wanted to use a tip ring sleeve connector on a tip sleeve system, that would be fine, because the ring just wouldn't be connected up, or it would really be soldered together with the sleeve. I can show you that here. So this is a tip sleeve jack. If you put it in there, you can see that the ring is not actually touching anything. So it's totally fine to, if you don't have a tip sleeve connector and it's an unbalanced configuration, but you do have a tip ring sleeve, it's fine. Just solder it up and leave the ring unconnected, and it's not going to bother anything. Okay. What do you do with these? Well, these are not so useful for microphone signals usually, but you can use these for line level signals. So the same sort of professional line level that we were talking about with XLRs, you can do that on 1/4 inches if they're balanced anyway, because you do have the tip ring sleeve. So the tip would be your positive or your hot, the ring would be your negative or your cold, the sleeve would be your ground. The disadvantage here is, as you can see, the conductors for a brief moment here become unparalleled. So there is a potential for interference here that is not a problem with the XLR. So it's usually not a major issue, but there's some potential there for a problem. The other thing that's interesting about these is they don't lock. Okay, there's no, whereas the XLR has a little locking pin, these don't. Okay, and it's just everything's spring-loaded. So there's just a little tab goes in there, and it just tabs in, and eventually that spring wears out in time. And, the more you plug it and unplug it, eventually those little springs start getting loose, and then your connection isn't quite so solid anymore. So that's a little frustrating about these. Neutrik did make a 1/4 inch jack that I don't know how they did this, but it does manage to lock. And this is it. So I can put this in there, and I can't pull it out. I don't know how this works, but you can push this little tab, and then it'll come out.
Like rubber expanding or something?
No idea. I've looked inside of them. I just don't understand how it can stop that thing from coming out, but it does. These are expensive, and they take up more space, right? You can see that the whole mechanism takes up more space than this would. But if you really want a locking 1/4 inch phone plug, this is the way to go.
And it works with both TS and TRS.
I don't know. Let's see. Should. Yeah.
So then maybe it's on that.
Yeah, I mean they're certainly grabbing the tip somehow, but given the way the tip is constructed, I don't see any way you could grab that so tight that it would not come out. I mean, it'd have to be really, really tight. So there's they've kind of mapped this groove in such a way that just locks it right in there. Oh, it's very clever. So you can use these for other things too. So a lot of times control signals will use these. So like pedals or remote buttons and stuff like that will sometimes go on these. A lot of processing and mixing consoles and things will use these because they take up less space than the XLR. The XLR is wonderful, but it takes up a lot of space. You can fit a couple of 1/4 inches in the same space that an XLR would take up. So if they're trying to make a thing that's smaller, you might find the 1/4 inch connectors on them. Another weakness of the 1/4 inch is, and you can almost see it on this one, is that sometimes they can bend. That's not good. Also, because the conductors don't stay parallel, they will pop when you plug them in and out, whereas the XLR won't. And the reason is that the ground is disconnected before the signal is, and that's what makes it pop. Plug them in and out is the connections don't happen simultaneously. So that's kind of a weakness. One slight little gotcha is this is the Neutrik version, which again requires no tools, which is wonderful. But in order to do their fancy toolless strain relief, that doesn't require, some of these, sometimes the quarter-inch connectors will require that you put a little, you have to put a little sleeve around, or this one probably has it. You have to put a little like plastic sleeve around the connectors here so they don't short out to the barrel, and that's kind of annoying because you can lose that sometimes or melt it when you try to solder it. Neutrik figured out a way around that. They can kind of sheath the whole thing with their strain relief includes that barrel in it, but in order to do that, they had to kind of make the barrel of the connector itself flanged a little bit, which means that while the front of the connector is fine and uses up, let's see, this one. So the actual plug itself is fine; it goes in and everything. The back end of this thing gets wider. It's not a big deal unless you have a whole bunch of them right in a row, and then they start butting up against each other, and then they start doing this. They start spreading out, and that can wear out your springs, mess your connections up, and all kinds of things. So just got to keep an eye on that. If you've got something like that has really tightly packed quarter-inch jacks, you want to make sure you get the sort of barrel on it that's straight. This is also a Neutrik connector. So anyway, that's just something to watch out for. These if you want. Just the different things. There's some variations on the theme. One you've probably seen before. This is called the 3.5 millimeter phone plug, or the 1/8 inch phone plug. And this also comes in a tip sleeve or a tip ring sleeve. The tip ring sleeve is, you all have them on your laptop. Your little headphones that came with your iPod, use that. In fact, the newer ones have like a tip ring sleeve because one of them is used for a microphone signal. So all the same strengths and weaknesses, just smaller. And the smallerness of it makes it a little more susceptible to damage. They break a little easier. They're harder to solder up and connect and everything. Not really reliable in any kind of professional situation. The quarter-inch is already sketchy enough. The 1/8 inch, it just makes it worse. So sometimes these are called mini jack. I don't really like using that term. It's awfully non-descriptive. So I prefer either 3.5 millimeter or 1/8 inch. That's the diameter of the connector itself. Mostly used for headphones, consumer-grade headphones. Some other variations on the theme. This is the military phone plug. This is much more like what the original phone plugs were for the telephone system. So while the telephone companies kind of moved on and now they have like automatic patching systems and everything, and it's all computers do it now. The military kind of adopted, and still to some extent I believe uses these sort of patch bays to do their field comm. And so that's why we call it the military phone plug. So it looks an awfully lot like a quarter-inch, but it's not. If you look closely and compare it, you'll see that it's ribbed quite a bit differently. So it will fit into a quarter-inch jack, and vice versa. A quarter-inch plug will fit into a military jack, but because they're ribbed differently, you can really, really destroy the military patch bay by putting regular quarter-inch connectors in there. It will wear out those springs really, really fast. So these are used primarily in patch bays. So you'll see this a lot in patch bays in theaters. We have managed to eradicate them from all of our theaters except the Stevens Center, and swap them out for XLR patch bays. And the advantage of the military patch bays is they're cheaper, easier to set up and everything, but they're really bad because they wear out. And they wear out primarily because they look just like quarter inches, and people try to plug adapters straight into them, and they'll wear out the jacks, and then they won't connect anymore, which has happened to a lot of the ones like in Stevens Center. That being said, it's a balanced signal, it's a tip ring sleeve, all the same sort of deal with a quarter inch, just a little bit different. So it's called a military phone plug.
Why is it different if it serves the same purpose? Is there something else that it does that the normal one doesn't do?
It's just a repurposed technology. So it wasn't designed to be used in live audio theater systems. It was used to do communication systems, and we've just repurposed it for that. So it's a cost thing. You can just get them because they're made for somebody else, and they make lots of them. The military makes lots of these.
So was this the original design of a
I don't know.
plug?
I don't know for sure, but it was much. My understanding is that the original was much closer to that than what we have now as the quarter inch.
Okay. So then, our now quarter inches evolved essentially from that.
I believe that's my understanding. The military is considered an inferior design because of the way it's ribbed. It wears out a little bit easier. That being said, it's still used for patch bays. I don't like that it's used for patch bays, but it is. This is another version of that. This is called the TT, Tiny Telephone plug. It's very, very similar to the standard military phone plug. It's just smaller. Again, used for patch bays. Mostly in recording studios, recording studio control rooms where they just don't have the space for massive patch bays. They'll do these to just patch processing in and out and stuff like that. I still use them in even high-end recording studios. Still use these.
But they probably can't have the right connectors for it.
Yeah, I mean they start because it's smaller. This is in some ways preferred over the military because there's really nothing else that's like this. So you're not likely to put the wrong connector into it and mess it up. So these tend to last a little bit longer, I think. So yeah, mostly patch bays.
Is that an 1/8 inch, but it's just longer?
No, it's bigger than
it's
a different diameter. Yeah, it's totally different. I mean, you can try putting that in your headphone jack.
Oh, yeah,
it won't even get in there even close. Let's see here. What else do I have in my bag of tricks? Another one here. Where is it? Did you go? Had you? Where did you go? Oh, there it is. Okay. These are phono connectors, as in phonograph. So technically that's what they are. Although usually we just call them RCA connectors because that's who invented them apparently. Technically phono, but we never call it that. We call it RCA. This is used for mostly consumer line level. So it is a coaxial connector. Coaxial meaning that you have the signal in the center that is surrounded by the shield. So it's a coaxial design. In some ways, the XLR is sort of like a coaxial design as well. sort of. But the idea there is that the relationship of the shield to the conductor in the center is always consistent. It never gets spread out or staggered. It's coaxial. It's coaxially loaded. In other words, they both share the same axis, right?
So does it have a coaxial cable like the PNC cables?
Yeah, so coaxial just means it's coaxial. Two things or more than one thing sharing the same axis. Okay, so in this case, the pin and the barrel have the same axis, that same center axis. That's all it means. So any wire that has a center conductor and an outer shield that shares the same axis is a coaxial cable. Okay, so yes, these would use coaxial cables. Otherwise, why would you go to the trouble of using a coaxial connector if you don't have coaxial cable connected to it? All right. So yes, these are used for consumer line level that don't require balanced signals. Because in the consumer world, you're rarely transmitting any audio more than a few feet, right? It's just like between, your DVD player and your receiver or something, and it's like a couple of feet. And how much trouble can it get into going a couple of feet? Not much, right? But traveling a few hundred feet, like we do all the time, there's all kinds of trouble it could get into. So you need that balanced signal. So the consumer line level is a little bit different. It's a little bit lower voltage than the professional line level. The impedance is slightly different. It's not going to be really good for traveling really long distances. It's just going to crap out and pick up lots of interference. So this is okay for short runs. But anything more than a few feet, I would definitely go with a balanced signal. Here's an interesting just little tidbit of information. You can have unbalanced on one end and balanced on the other end and still get all the benefits of a balanced signal. You know why? Because if you if your hot pin on the balanced end is going to your tip on the unbalanced, and the cold and the shield are both soldered to the shield of this, guess what? You still have differential. Okay, on the end that receives the balance signal, remember it's looking for difference. And there will be a huge difference between signal and crud. Okay, so the crud's going to get introduced to both things, right? Both the center tip and the shield, and so it will see that difference when it spins it back out on the other end. And so if you solder it upright, you can actually get the benefits of both.
So it can only go one way, though.
Yeah. Yeah, if the receiving end is unbalanced, you're out of luck. But so anyway, that's just a little tidbit of information. It's called pseudo balanced, but you get a lot of the same benefits. The only benefit you don't get is you don't get the 6 dB boost. So the balanced signals are 6 dB hotter than unbalanced because of the summation that happens with the two signals. But you don't get that with the pseudo balanced. It's not quite the same, but you do get essentially all of the noise rejection capability, which is kind of cool. All right, so yeah, consumer line level audio. This can also be used for video, composite video signals or component video signals. Really any consumer video equipment is going to use this. There's a digital audio protocol, Sony Philips digital interface, SPDIF, I like to call it. It's a 2-channel digital audio signal, consumer grade. You can just run any sort of digital pulse down it, which is used a lot for just like surround sound digital audio. It can be encoded into just a digital pulse code, and it'll go down there just fine. So lots of stuff use this. It's not really great for a professional application, but there you go. It's got some of the same weaknesses of the 1/4 inch in that you see the ground comes loose before the signal pin does, which means it'll pop. So interestingly enough, Neutrik has made a spring-loaded RCA. where the barrel here is spring-loaded, which means as you put it in,
The ground hits
they
first.
both, yeah, the ground hits first, and they both disconnect at essentially the same time. So this one won't pop. Yeah. So you must use an RCA in a professional situation. You should use this one. Okay.
Does Neutrik kind of have a bit of a monopoly on the connector market, or are they?
They're just very clever,
very
and
good?
they're just very clever, and I like them. So I'm
'Cause
always,
all I ever see is Neutrik. So.
yeah, because we like them. Manufacturers like Switchcraft because it's cheaper, especially U.S. manufacturers because it's made in the U.S. But in my opinion, Neutrik is the superior product. The headquarters for the U.S. headquarters for Neutrik are actually in Charlotte, North Carolina. Interestingly enough.
You got D&B in Asheville.
Yeah.
Neutrik.
So that's kind of cool. All right, let's see what else I can come up with in this universe we're in right now. Here's an interesting one. This is an amphenol connector. AMPHENOL, amphenol. This was the precursor to the XLR. So I've got a couple of old microphones from the 40s and 50s in my office, and they use these 3-pin amphenol connectors. It's very, very similar to the XLR, except it just uses like a little screw ring into it that locks it into place. And amphenols are still used today for usually for multi-pin snakes. You can get big, massive amphenols that have tons of pins in them. Same sort of design. You stick it in there and then screw the ring down. It'll go in there. But if you ever see this on a microphone, that's what it is. It's called the 3-pin amphenol. You can still get these. Some places, and I've had to make adapters for them before when I wanted to use my old mics on shows. So anyway, 3-pin amphenol. So you won't see it very often. It's just kind of a interesting thing to look at. What we had before.
So the only thing that's really different is just where the pin placement is, like.
Yeah, the pin
they're
configuration is a little bit different. It is not necessarily a balanced signal.
Why is that? Even though it has
Just
3
because the
pins?
mics used to be high impedance microphones, before the days of the front of house sound engineer with the mixing console, you would just plug the mic straight into the guitar amps and stuff.
Mm-hmm.
So they were only going like 10 feet. They weren't going any further. So the output of those microphones is very similar to the output of an electric guitar.
Okay.
Those old microphones, and it wasn't until later when they realized, well, maybe we should put the sound person out, in the theater. Then it's like, well, now we got to figure out how to transmit those microphone signals further distance. And so, like my 1942 mic is a unbalanced high impedance microphone, but then my 1951 mic actually has a switch on it, which switches it between 2 different unbalanced impedances and then a really low impedance balance signal on using the amphenol. Both use the amphenol, even the 41 mic though. So it just depends on the microphone what you're going to get. Let's see here. Find some things here that are similar. Try to stick to the low voltage stuff today. We'll get to the higher voltage stuff later, Thursday, hopefully. Oh, by the way, you saw on the schedule that a week from Thursday I'm in tech, so we don't have class, and then the following Tuesday we won't either. So don't show up here and wonder where I am. Let's see. Okay, so these are a few different sorts of connectors you might find on wireless mics. So this is the TA connector. There are different pin configurations for this. Sometimes this is called the tiny XLR. I don't really like using that because I just don't, but technically it's the TA connector, and you can get it in different pins. So you have a TA, this is a TA4, you can get a TA3, this 4-pin, 3-pin, so on and so forth. The TA4 is used on most of the Shure wireless microphone transmitters, belt pack transmitters anyway. It's not actually a very good connector. It's got a lot of plastic in it. It does have this little locking pin, but the mechanism is really not real reliable. But it's inexpensive, and for whatever reason, Shure has adopted it. They're a pain in the butt to solder, so I usually don't. I should have the manufacturer do those for me. But you know, they're a thing. You also see these sometimes on some like floor microphones, and PZM microphones will sometimes use like a TA3 connector because an XLR is just like too big to try to cram into a little tiny mic. So if it's a small microphone, you might see this on it. TA connector. That's a TAF for female.
What are the 4 pins used for?
Well, it's depends on the manufacturer. They all do it a little bit differently. In some cases, I mean, most wireless microphone elements are really, they're not balanced per se. It's usually a high impedance, unbalanced signal on there. So it really only requires 2 conductors, but sometimes to reduce handling noise, they'll do some hocus pocus inside the connector with a couple of the pins and put a little capacitor or resistor in between it. It does something to do with, it like filters out the DC noise that gets put in there. There's all kinds of funny things. So it's not always, this is why I say it's a pain to solder, because it's not always just like wire to pin.
Mm-hmm.
There's sometimes some electronics you have to put in there to make it work depending on what sort of microphone is connecting to what sort of receiver. So it's different for each manufacturer, and it's not something that I've ever really taken a lot of time to try to ever understand, because usually I just order the mics with them already put on.
Right.
Because I've tried soldering
like
them.
the Countryman's?
Yeah, I've tried soldering them before, and it's awful. Because there's so much plastic in them, they just melt. So this is called a LEMO connector. And I don't know what exact.
How do you spell it?
LEMO. There's tons of different configurations of LEMO. The LEMO design is this sort of like spring-loaded barrel design, where this little barrel sort of pulls down and the pins drop. Then you can stick it in, you'll release it, and it grabs in. So that's the actual LEMO design. And then what happens inside varies. I mean, there's hundreds of different types of LEMOs. These are, the advantage of these is they're for the most part an all-metal design. So there's not an awful lot of plastic in there, so the mechanism is more reliable. It's a more reliable connection. That being said, they're much more expensive and heavier connector, but it's much preferred over something like the TA4 if you can get it. So I believe like Sony uses these on some of their high-end wireless mics. Sennheiser uses these on some of their high-end wireless mic transmitters. Very expensive, but much more reliable.
Is it because of that locking mechanism?
Yeah, it's just a more complicated connector design, I guess. And there's a couple of different types. I'm not sure which one that is. I think that's the Sony one, actually.
Do you have a female one of those?
Not with me. You can get the Shure UR series, UHFR series, belt packs can have LEMOs put on them instead of the TA connectors, but it's a more expensive option. It's an upgrade when you order them. This is the micro dot. It's very, very simple. It's just a little coaxial connector, and the little screw ring is kind of spring mounted in here, so it pops back when you undo it. This is another connector used on wireless mics. DPA uses these on all their little teeny mics, and then they sell you adapters that go from microdot to whatever, to TA4 or LEMO or whatever. I guess that's easier for them. Also a real pain to solder, I'm told. I've never tried to do it.
Is it basically just a tiny coax?
No, it's a small version of this, sort of, this is called an F-type connector.
Okay.
Which is used primarily for like cable TV.
Right.
It is a coaxial design, but it's a bit of a misnomer to call this a coax connector because it's like, well, yeah, but
What is it?
yeah, it's like that describes its characteristics, but it doesn't actually
What type of
describe what it is, right? It's like, addressing Brian as redhead guy. It's like, yes, he is a redhead guy, but which redhead guy is he of the millions that are out there? So I would prefer not to call this coax because, well, yes, but. So it's technically an F connector, and this is so the microdot is just a really small version of the F connector, really. The difference is, whereas the F connector really doesn't have a pin in it, it just has the wire sticking out from the cable, whereas the microdot actually crimps or solders the wire to an actual connector pin that goes into it, so that's a little bit different. So the F connector is mostly used for television, cable television, or antennas, consumer TV antennas and stuff. It'll use again a coaxial type cable, but has a really, really solid core center conductor that is suitable for really high bandwidth stuff. It can handle a much wider frequency range, which is how they're able to pack so many channels and that plus internet and everything on it, because it's just massive, massive bandwidth available in there. Similar design is this, which is the BNC connector, bayonet connector, bayonet something connector. And BNC is a bit of a misnomer too. It's not, that's what everybody calls it, but I believe there's actually a more technical term I've never bothered to learn, because usually the BNC is descriptive enough to identify this thing uniquely. This is also used for video signals. You can use for other things too. The difference is this to be used for what we call composite video signals, whereas the F connector would be used for what we call RF modulated video signals. It's a different way of sending the video down. Also uses pretty high bandwidth coaxial cable. The advantage of the BNC is that it's a little bit easier to connect it and disconnect it. It's got a cool little locking mechanism, whereas the F, you gotta screw it a million times. So the other cool thing about the BNC is instead of just using the wire as the pin like the F-type, this actually has a pin that gets soldered or crimped to the wire, and that's a little bit makes it a bit more consistent in the way it connects in, which is nice. So this is also used for word clock signals, which is like a digital synchronization signal between digital equipment, digital mixing consoles or things that could do that. There's also a protocol called MADI, which is a digital audio protocol that encodes. It's very similar to AES-EBU in the encoding method. The protocol is very similar. It's just it packs, up to 64 separate audio signals onto one cable. Requires a really high bandwidth cable, whereas if you're just going to use this for a cheap CCTV camera, you can use a stainless steel cable, which is a lot of the video cable we've got here. But for MADI, you really want something that has higher bandwidth, so that it can record, because the MADI is a digital signal, whereas composite video is an analog signal. So the analog signal has sort of a curve to its sort of wave shape that's running down there, whereas a MADI is a pulse. It's like a square wave pulsing up and down. And a square wave requires lots of harmonics to make that square, really, really high harmonic frequencies. And when you get lower conductive cables in there, it will not be able to reproduce those high harmonics, and therefore the square waves will become curved and can be rejected because they won't be recognized as a full pulse in some cases. So it's the same connector, but ultimately you really make sure you get the right cable hooked up to it. You can also, we also use these. This one is particularly used for antenna connections, for wireless mic antenna distribution. Again, you have to use a certain kind of cable there. You want to use really what we call low loss 50 ohm cable. So most of like your video cable and like Maddie is what we call 75 ohm. For antennas, you really want 50 ohm. Otherwise, you get too much line loss as a result of running that signal that distance. So it's a different type of cable, and I'll show you some when we get into cables later. So that's BNC, used for several different things. How are we doing on time? Good. If you got questions, shout them out. Let's see.
Oh, is BNC balanced? Did you say? No. So then, it's only the cable that is required, the low loss, is what keeps it from getting interference?
No, it's not about interference. It's about degradation of the signal just by virtue of it traveling a long distance.
Okay.
How long can it travel without?
Depends on the cable.
Because I know Guys and Dolls are running everything through Maddie from backstage.
Well, that's Maddie. So Maddie, you can theoretically do 100 meters.
That's about
Right.
a little less than that.
So, which is about 300 feet or so.
Yeah, that's like a football
Sorry,
field.
100 feet, yeah.
So it'll, that's kind of the limit of it. Which
So then,
you're well under that.
what about do cables like that get interference or?
Yeah, they're shielded really well though.
Okay.
So that helps quite a bit. They're also coming down at a much higher voltage, which also helps.
Because then the signal is louder than the noise.
Yeah. However, in the antenna world, it's not. It's actually pretty low level
That's
coming
what
off
I'm
an antenna,
wondering about.
which is why you need really low loss cable so that the cable itself is not degrading the signal. So the longer you go, there's some resistance to that cable, right, and it's going to impede the signal to a certain extent. So you want it to not do that to the extent possible.
Mm-hmm.
And you can amplify. You can put amplifiers on it, so like pre-amplify it off the antenna coming in if you want. But you can actually run the risk of clipping the signal if you over-amplify it. So anyway, the idea there is you want to make sure it's as low loss as possible and really well shielded, so that when you get that really small antenna signal arrives at the other end, it's still intact and it's enough that the receiver can then amplify it and use it. So you don't want to use cheap video cable for your long antenna runs.
So we have good. Okay. Because
Yeah.
for most it's very, very, very long.
This is an example of
Wow.
this is the best antenna cable money can buy. This is a custom antenna cable that's manufactured by Belden, but it's specified by Professional Wireless, which is a subsidiary of Mask Sound from New York. And they sort of designed this this spec for this cable, and Belden made it for them, and it's really amazing stuff.
Is that
but-
solid?
No, it's stranded, which is normally it would be solid. A lot of antenna cables solid. This is stranded, which makes it more flexible.
Mhm.
But this is really super low loss. It's very expensive. It's like $1.50 a foot for this stuff.
Big long cable.
But you can see how solid this shield is. I mean, it's stuff. We'll talk more about that later. All right, this is a Phoenix connector. You can get these in lots of different pin configurations. These are 3-pin ones, but you can get multi-pins out of these, but they're all done in a row. This is primarily used in permanent install equipment, so system processors and things that are going to live in a rack and be connected once and never touched again. They take up less space than the XLR, cheaper. So if this is, again, if a permanent install situation, if you're going to install something in a rack and it's going to sit there for 20 years,
So a lot of patch bays use them.
no, not patch bays, but like system processors and stuff. Like on the back of that, some of those processors in that rack probably have Phoenix connectors on them.
What about on the back of patch bays?
That's what I meant.
Oh, I haven't seen that an awful lot. Usually in the back of off-the-shelf patch bays, it's like punch downs. So it's like it's a row of like little slotted holes that you can just like punch the wire down onto it, and it slices into it. That's different from this. This is actual connector, so the device will have a female version of this on it.
Is the punch down, you kind of just screw it in?
No, you just like,
it?
no, you literally stick the wire on top of it, and there's a little punch tool. You like jam it in there, and it pierces. It's got a little some blade in it essentially. It pierces through the jacket and comes in contact with the wire inside. So if you're like setting one of these up and you're going to do 1 million of these in a day, you don't want to be soldering all these in. You're going to connect it once. It's never going to touch it again. It's never going to get pulled out. You're going to strain relief the crap out of it. So I mean, these guys just like they fan all these out and they set it up there and go boom, 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 and they just punch right in there. Which is what this thing is trying to do. That's the equivalent of this, but then you're going to move this around all the time, which is going to be pulled out. So there's nothing holding it in.
Oh, right.
So anyway, you'll see this a lot on the back of processors. Like, where are they? You can see them through this page somewhere here. Yeah, so like on the back of this PGPIO from the Dimitri, you see those orange ones, those are Phoenix connectors. There's a few different sizes of these. That's a smaller size than this one, but the upside to this is they're much cheaper and take a lot less space. Downside is, there's nothing locking them in. There's no locking mechanism. They can come out really easily. But the idea is there will never be strain on this. So this will be connected in and then tied off with a zip tie to some panel or something and never touched again. So that being said, if you find yourself using something that is designed to be permanently installed somewhere and you're using it in a portable situation, be careful with these. Usually what you would want to do is we have some of these. Actually, grab one, I'll show you. Here's a little XLR patch panel that we made that has Phoenix tails on it. The idea is you would plug in the Phoenix tech to the processor you're using and then never touch it again. And then this is what you do all your patching with, and that way you're not messing with this thing that's going to come out all the time. So that's one way you can get around the sketchiness of using a Phoenix in a portable situation. Thing to be aware of, oh look at this, you can. There's the pin out for this there's no standard for how this is pinned out. It's just decided by the manufacturer that puts it into their thing. So you can't assume anything as far as what pin goes to what thing. So this could be a microphone, this could be line level audio, could be some sort of control signal, could be MIDI, could be,
You set that up yourself.
Well, no, you have to figure out whatever the person who made the piece of equipment that is putting this connector on it, that they're going to have their own pin out for whatever signal they're putting on it.
Okay.
And hopefully it'll be screen printed on the back, or if not, it'll be written in the manual. So you have to look it up. That particular patch panel is wired up for the pin out for a PV media matrix processor, because their pin out for balanced audio is different from another processor we have, which is from BSS called a SoundWeb, and the hot cold ground is laid out differently on the same connector, but two different processors. So something to watch out for. This green was a better design because it has a built-in kind of tab that you can do a zip tie strain relief to, whereas this one doesn't. So this is like tough. You basically strip the wire, don't solder it. Don't tin it, solder it, because otherwise the little clamp, you do a little screws into here and it tries to clamp down on it. And if the wire's been tinned, it won't compress, and so it'll come out really easily. All right, so that's Phoenix. Here's another sort of antenna type connector. I usually call these a UHF, but it's technically a PL259. And there's a couple of other. The female is another little number. I forget the difference. This is used. Usually, we just call them UHF. Can also be used for antenna signals. This was used for, interesting enough, the VHF wireless microphones that we used to have from Shure. This is much easier to solder than a BNC is to solder to a big 50 ohm antenna cable. You saw the size of that conductor. Imagine trying to cram that into a little teeny BNC pin. It's tricky. So this is a little bit easier. So a lot of times what we'll do is we'll terminate our antenna cables with UHF PL259 connectors like this, and then you can buy little adapters that go from that to BNC. Those little just barrels that screw on there, and that's a little bit easier to deal with. I've got some over here, I'll show you. Bought these from a ham radio supply company. So it just kind of screws into there. Now it's BNC. Okay. Very handy. They used to sell these at Radio Shack, but Radio Shack is not long for this world, it appears. So these are unsoldered PL259s if you just kind of want to see how they look. There's little two parts to them. You can look at these two if you want. Okay. Let's see. I'll stick to the low voltage stuff today if I can. Okay, here's just a mishmash of various things. This is called a DIN connector, D-I-N, which is an acronym for some German standardization, electrical standards, Deutsch International, something or other. It's a DIN. So the standard is the size of this barrel, and then the pins inside there could be anything really. This is called a 5-pin 180-degree DIN. So it has 5 pins, and they are arrayed in a 180-degree arc. We use these for MIDI. So MIDI uses a 5-pin 180-degree DIN. You can get, just FYI, 5-pin 270-degree DINs, which would not work with MIDI. So just saying I want to order some 5-pin DINs isn't necessarily going to get you the one that'll work with MIDI. So the one that works with MIDI is a 5-pin 180-degree DIN connector. So used for MIDI signals, you'll learn more about MIDI in coming years, but it's a digital control protocol, and we can use it for all kinds of stuff. Interestingly enough, just like DMX, it only uses 3 of the 5 pins, which means you can run this down XLR cable too. We have lots of 5-pin DIN to 3-pin XLR adapters in the shop and in the lab when we got to run MIDI long distances. It's much easier to do that over an XLR cable because we have big snakes and everything to do that. And you can run MIDI much farther than the 50-foot spec claims. They say you should. They spec it for 50 feet. I've run it a couple hundred feet before. It's fine. The only reason they said 50 is like they couldn't envision anybody ever wanting to run it further than that. It's like, why would you have more than 50 feet between your keyboard and your synthesizer? It's like, well, we sort of thought of a few other things to do with it after that. This is a miniature DIN, mini DIN. Again, with different. This is a mini DIN 8. So this can be used for lots of things. This particular one, I believe, was used for the old Mac computers. Used to use this for their serial connection. It was an RS-422 signal serial connection. we have like some CD players that use this as the connector for the remote control. The old sort of PS2 style keyboards use a mini DIN connector. S-Video, if you've ever seen S-Video, Super Video connections, that's a mini DIN, 4-pin mini DIN.
What was this video ever used for? Was that in place of like the red, yellow, white?
Yeah, so it was it was sort of an intermediary between the straight up composite video signal and what we would call the component video signal, which is where they split out the colors. So Super Video, it would actually, there was 4 pins in there, and it would, I never really understood exactly what was happening, but it was spreading out the color in a way that made it look a little bit nicer.
Would you just use the S-Video?
Yeah.
You wouldn't use any of the
that'd be your full video signal in the S-Video. So it wouldn't quite handle high definition, but it will handle, the color was a little bit better.
Mm-hmm.
So mini DIN, you'll see these in lots of different pin configurations. This is why sound is so hard, by the way, because we have like so many different, connectors. Like trying to connect everything up together is just a mess, because it's not like lighting has got it way easy. They really only use a handful of different type of connections. Let's see. This is a D-type connector, and the D will, because it sort of looks like a D. You see the shape of that. Here's another version of the D connector, and the D will usually be followed by another letter. An A, B, a C, or a D, or an E even, and that has to do with the size of the pins inside of it. So this is a DB. This particular is a DB connector. It's a D connector with B-size pins. Also DB, B-size pins. So this is a DB25, because that's 25 pins in it. Used to be used in like printers and computer stuff. Nowadays, they've experiencing a bit of a resurgence in the sound world because you have a lot of devices that are having multi-channel audio output, and trying to do that with a whole bunch of XLRs is a pain in the butt. But they don't want to do it with quarter inches because quarter inches are sketchy. So they do it with this, and this takes up very little space, but it locks in. You screw this thing in and it stays put. So you can actually buy fan-outs for this that go from DB25, and you can have 8 channels of balanced audio running on that. So you can do it. You can do it with just regular balanced audio. You can do it with AES EBU. We've got the snakes for that. All kinds of things can do that. So some sound cards will do that. We have some Focusrite RedNet interfaces. You may have seen those on the shows that have DB25s on them. 1 through 8 and then 1 through 16, and you have tails that go out to XLR to patch you into something. So these are being used much more often now for that kind of stuff, multi-pin connections.
So this one is on the back of the SD10, right?
I believe the SD10 is like, it's not a DB25, it's like a DB.
But there's 2 different ones, I think. Different sizes.
Yeah, so like there's like what they call a general purpose I/O that has like relay and contact closure input and outputs, and it's using something like that. I don't think it's 25. It's a little bit bigger. It's like a 32 or something. But yeah,
It's the same idea.
It's breaking that. There's a tail you can build that breaks it out to lots of different types of connectors to do all kinds of things with. So this is a DB8. Most of your old computers that use RS-232 is going to serial connection will have this on there, but you see it used for some other things too every once in a while. For like we have a digital that Mackie hard disk recorder up there has this on the back of it for its MIDI cable. So it's MIDI because again they were trying to get it to fit into a card slot, and the DIN connectors were too big for that, so they put this on it, and then shipped a tail that fans out to 2 mini DIN 8 female connectors for MIDI in and out. This is, I don't remember which pin size this is. This is another D connector. I don't know if this is, I think this is DE. Very, very small pins. This is like a DE50 or something. Again, just another kind of variation on the theme. This particular one, I believe, was used for some sort of SCSI hard drive, old hard drives we used to use on computers. However, you'll still see these sometimes, little ones like this, like console links. If you're going to like slave one console to another, sometimes they'll slave up with really tightly packed ones like this. Instead of screws, it's got these little spring-loaded tabs that grab it, which is makes it a little bit easier to deal with. Another variation on this. This is actually called a Centronics connector. You don't see this one as much anymore, but primarily this was used for SCSI hard drive connections. And we still have a couple of samplers that use this for the SCSI hard drive connections. Printers sometimes have used this in the past. So you won't encounter this one too much anymore. But
What's that called again?
Centronics, C-E-N-T-R-O-N-I-X, I think, or C-S. Oh, here's another variation on the DIN connector. This is like a 2-pin DIN. This was probably used for power, like a DC power connector for something. Just to show you there's more than one way to do that. All right, I think that's all I got time for. I didn't quite get to all the low voltage stuff, but we'll do some more on Thursday.
Why are these all?